I have a couple of problems here that are similar to what we're going over on the test, right? The other video that I'm posting along with this is about sketching a graph, sketching a function that is in factored form on the graph. And there's a few elements of that in here, like trying to find the zeros or the x-intercepts, right? But if I'm given this like problem here, right? If x minus 4 is a factor of 2x cubed minus 9x squared plus 3x plus 4, and it's tasking me with finding all of the zeros of the function. I know that in order to find zeros, I need to be in factored form. But this function over here is in standard form, right? X cubed, then x squared, then x, then 4. So if I have this standard form function, and it tells me that x minus 4 is a factor, I can factor using my box method or my long division. I'm going to choose to do the box method for now. I think I might also show how to do the long division. But I know that my box has to be 3 boxes wide. Why? Because we have a degree 3 polynomial. Remember, degree is our highest exponent in standard form, not necessarily in factored form, but I know that we need 3 boxes. And then since we're going to be dividing by this x minus 4, so that x minus 4 is going to be on the side. We might see this problem worded a bit differently. You might be given the start of a problem where it says 2x cubed minus 9x squared plus 3x plus 4 all over x minus 4. Pretend that looks more like a fraction. And then it'll be like equals blank. That's just telling you to divide by x minus 4. It's the same process, just another way of asking the same question, right? So let me erase that with my big eraser. Anyhow, right, that division is the same process. So anytime I'm dividing, and I know that this is a factor, it's telling me that. It's saying if x minus 4 is a factor. I know that I don't have to worry about a remainder in this problem. So I'm going to put my 2x cubed from the function in my top left. And I'm going to put my number 4 in my bottom right. I don't really have like highlighters or nothing, but like this 2x cubed is this, right? It's directly from the function that we're given. And then we know that like our diagonals, right, these two boxes, they're going to add up to this negative 9x squared, right? So I know these are going to be x squareds. And then I know these two diagonal boxes, they're going to add up to our 3x. So I know these have to have just x. So now I got to actually solve. So x times what gets me to 2x cubed? I can write it out over here. X times what equals 2x cubed. Well, I know that x times x squared gets me x cubed, and this is the same as 1x, so 1 times 2 would get me the 2 in front of our x cubed. So that means up top, I'm going to put 2x squared. That's what I found in my blank here. Get rid of it. I need room. So then, I know I have 2x squared. 2x squared times negative 4 gets me how many x squareds? Well, 2 times negative 4, that's negative 8. So in my bottom left box, I get negative 8x squared. So I have my left column done. Now I have negative 8x squared, And I know it's going to add with this top middle box to get negative 9. So negative 8x squared plus what? Or how many x squareds gets me my negative 9x? Well, I know negative 8 plus a negative 1 would give me negative 9. So this has to be a negative 1x squared. In order for that to be a negative 1x squared in the box, I know that this x times a negative 1x would give me negative 1x squared. Again, I could write that in an equation, like x times how many x's gives me, x times what gives me negative 1x squared. That's just negative 1x, right? Some of them's done. No, I don't want my big eraser. I have this negative 1x, and it's multiplying with this negative 4 to get our bottom middle box. Well, I know negative 4 times negative 1 is just 4x. And then again, I have 4x, but I need to get that 3x in my function. So in order for 4x plus something x, why is it doing that? Hold on. Plus something x equals 3x. Please let me write plus 3x. I know that 4 plus, again, a negative 1 will give me that 3x. So in my top right box, I need negative 1. No, that doesn't look like a 1. I would need a negative 1x. So again, x times what equals negative 1x? That's just negative 1. So I put negative 1 in my top box. So now I have a factored form of x minus 4 times the 2x squared minus 1x minus 1 that I just solved for up top here. But that doesn't mean I'm done, right? I need to still find the zeros. So I'm going to erase my box. Actually, I'll leave it just in case. You can pause the video just to write that down. But I'm erasing it. So now, where's my cursor? I have x minus 4 times 2x squared minus 1x minus 1. If you don't remember, this x minus 4 would give us a 0 at x equals a positive 4. Technically, you do like the x minus 4 equals 0. Add 4 to both sides, you get x equals 4, right? But I don't want that on my screen just because it takes up space. So we know that one of our zeros, I'm just going to write, that's x equals 4. Yeah. That's equal x equals 4. But I don't know what 2x squared minus 1x minus 1 equals 0 is. Like, I don't know how to find those x's right now. So I need to factor again. So instead of dividing polynomials, I'm just going to do a regular old reverse box method here. I know that it's got to be a 2 by 2 because it's a degree 2 polynomial. Oh, that's not. Good enough. I know that I have, come on, 2x squared in my top left, right? I'm always putting my highest exponent in the top left. And then I know I have negative 1 in the bottom right. The only time that we're not putting the number in the bottom right is if the question is posed as like, is x minus 4 a factor, right? So if you're ever asked, is this a factor? Or which one of these factors is a actual factor of our function, we can't put our number in the bottom right because we might get a remainder. But I might go over that again a bit later. So I have 2x squared. I know x times x gets me the 2x squared, or it gives me the x squared part. And then I know one of these has to be a 1, and one of these has to be a 2. Because 2 times 1 is 2, right? And then now, what two numbers multiply to -1, but the diagonals are going to add to a -1x? So let me actually put this in more color. These diagonals are going to add up to, why did it go away? -1x. Again, that's a -1. I know it's dumb. So there's really only two things that can multiply to -1. It's just 1 times -1, right? So what if I tried that this was 1 and this was -1? I could do my multiplication. That gets me 2x up here, and this gives me -1x. But then when I add those two diagonals, 2x plus -1x, that gives me a positive 1x, right? But I don't want a positive 1x. So that's not my factor. Instead, let me make my eraser smaller so I don't erase the whole thing. Instead, I just have to flip them. This has to be a -1, which makes this -2x, and this will be the positive 1 down here, making this 1x squared. So now, -2 plus a positive 1, that gets us our -1x. So again, when we're doing this reverse box method, there's going to be times where we're going to have to kind of guess and check. Like, will these two factors work and get me that middle term when I add? Sometimes it's a little more difficult than just, oh, which one's the -1, which one's the positive 1. Sometimes you'll, like, if this was like a -12 down here, I'd be like, I'd have so many factors to work with, right? I have 1 times -12, I have 2 times -6, I have 3 times -4, and then I have like -3 times 4, -2 times 6, right? Like, there's so many things I'd have to try and make sure that they add up to our middle number, or our b value. So now that I've done the factoring, I have, well, two new factors. I have x minus 1, or 1x minus 1, however you want to put it. And then I have this 2x plus 1 down here. So this I just split off into x minus 1 and 2x plus 1. Right? And I found that the 0 for my x minus 4, right, that was x equals 4. I wrote it back up at this top left bit here. For x minus 1, if I set that equal to 0, I'd add 1 on both sides, right? I get x equals positive 1. And then if I have 2x plus 1 equals 0, I subtract the 1 on both sides. I get 2x equals -1. I have to divide both sides by 2. That gets me x equals -1/2. Right? Does that make? I hope that makes sense. But there we go. Like, we're done now, right? We got all of our zeros. We got x equals 4, x equals 1, and x equals -1/2. Pretend I didn't just cut through the 1/2. So in this case, x equals 4, x equals 1, x equals -1/2. Those are all x-intercepts because they're all real numbers. If I ended up with like a 4i, that would be a 0 because it made our function equal to 0. But it wouldn't be an x-intercept because I can't graph it, right? That's a really important distinction that we've been trying to focus on. So now, I'm all done with that problem. I'm going to scroll down. Oops. Yeah, that should be fine. So now I have 4x to the 4th minus 16. I got to find the zeros of it, and I got to find how many x-intercepts there are. Right? They're different things. They might be different things. Crazy. So I know we had mentioned how the degree equals the amount of boxes we have, right? I see that I have a degree 4. So I would think, oh, this is going to be like a 4 box wide box. And you could keep it as a 4 box, or like 4 wide. I know that 4x to the 4th goes up here. Negative 16 goes in my bottom right. Well, I know that in this case, there's really only a couple things that can get us 4x to the 4th, right? I could have 2x squared times 2x squared. I could have 4x to the 3rd times 1x. Those technically do work. But when I see that I have just a x to the 4th in our problem, or if it was just like 4x to the 4th plus 2x squared minus 16, I know that in this case, I don't have any x cubes in there, I don't have any x's in there. So I know that I'm only working with x squareds. Because that's the only way I can get just x to the 4th and x squared is if I'm not multiplying by things that have x or x cubed in them, right? And then to get 4, I mean, obviously I see that, like, I don't end up with any x squareds in my function. So I know that these diagonals are going to add to 0. And then I know these diagonals are going to add to 0. Like, these are technically like the x cubes, but I don't have any x cubes to worry about, so I don't have to worry about those boxes. I don't have any x squares in my function right now, so I technically don't need to worry about those. I don't have any x's in my function, so those don't matter. Kind of. But what if I told you I could just write this as a 2 by 2? Mainly because this is only 2 terms wide. So like 4x to the 4th and minus 16 in my box, I know x squared times x squared is going to get us that. And then in order for these to cancel out, more than likely they're going to, or not more than likely, they're always going to have to be the same number but opposite signs. So like a positive 5 and a negative 5 would add up to 0 and cancel out. So I'm just going to assume that these are 2's multiplied with both of these numbers. Again, that assumption is only because I know that these add up together. I mean, I know on our previous problem, we knew that these diagonals add up to a negative 1x. And I tried one of the options. Like, you could try a 4x squared times a 1x squared. But it's going to be harder for them to cancel out. So again, it's unfortunate, but there is just some guessing and checking involved. So right now, I know that I need 2 numbers that multiply to negative 16, but add to 0. X squareds, right? I know that I'm going to have some amount of x squareds in this box, some amount of x squareds in this box, because like 2x squared times a number is going to give me some amount of x squareds. So if I'm trying to factor negative 16, I could have 2 times negative 8. I could have... Bleh. Give me my calculator. I don't know why I said that. I could have 4 times negative 4. I could have this 1 times the negative 16. I could even have, like, negative 2 times positive 8, right? But which of these factors is going to add up to 0? I know I'm going to need a 4x and a negative 4x squared. So I have a 2x squared minus 4 and a 2x squared, oops, sorry, and a 2x squared Dang it, I messed this up. Hold on. This is a 4x squared, right? 2x squared times a positive 4 would give us that 4x squared. And then down here, I would have a negative 4. So I have these factors, 2x squared plus 4 and 2x squared minus 4. Let me erase my box. I'm sorry if my explanation of why I can do a 2x2 was a little rough. Really, the only time you actually need to do a full entire 4x4 or 4x2 box is if you were given an equation that was like x to the fourth plus 3x to the third plus 6x squared minus x plus 5. Like, this has all of our exponents, right? It has a fourth, it has a third, it has a squared, it has an x, and it has a number. It's not always going to be the case that we have to do all that. I don't believe on the test you're going to have anything that involved because we haven't really done many of those 4x2 boxes. But I could be wrong. There might be. Who knows? I know. Anyways, I have these two factors, 2x plus 4 and 2x squared plus 4 and 2x squared minus 4. In order to find the zeros, right, we set them equal to 0. So I have 2x squared plus 4 equals 0. I'm going to subtract 4 on both sides because I want to get x by itself. So now I have 2x squared equals negative 4. But I still got to divide by 2. That gives me x squared equals negative 2. The reason why I subtracted first is because I want it to be just like one number equaling one number, right? When we have to divide or take the square root of multiple terms at a time, it's going to give us a lot of trouble, right? So I also divided before I took the square root because otherwise I'd have the 2 still there under the square root of 2x, the square root of 2x squared. That's going to be too much to worry about, right? So I want just x squared equals a number before I take the square root. So obviously now I'm going to take the square root because I want just x equals a number, not x squared. So I have x equals the square root of negative 2. Well, I know that it's got to be plus or minus because that happens every time we take the square root of x squared. It'll give us a positive number and a negative number. But then I also see that I have a negative under my square root, right? So this is actually going to give me two x values, right? This is going to give me x equals a positive square root of negative 2. Well, I know the negative gives me an I on the outside, and I don't know how to take the square root of 2. That gives me some decimal, so I'm just going to leave it. I'm going to leave it under the radical. And then I know I also get x equals a negative I square root 2. So remember, anytime we take the square root of that negative number, that's going to give us these i's out front. And that's bringing that I out front basically gets rid of this negative sign inside inside of our radical, allowing us to actually do the square root. So I have a positive I root 2 and a negative I root 2. And then I know I've got 2x squared minus 4 as my other factor equals 0. I add 4 on both sides. Right, I get 2x squared equals 4. Divide by 2, divide by 2. I get x squared equals 2. Hold on, I need to make some room. Let's just get rid of that. I'm going to take the square root of these, right? So I get x equals a positive square root 2 and x equals a negative square root 2. I know my notation doesn't look perfect, but this is a negative root 2. So I found 4 zeros, which makes sense, right? We have x to the 4th, so I should end up with 4 zeros. We had talked about how whatever our degree is tells us how many zeros we're going to have. And I see we have, let me let's pick purple. I have 1, oops. I have 2 here, and I have 2 here. But then it asks me, how many x-intercepts are there? Well, even though I don't know exactly what square root of 2 is, I can graph where that is. It's somewhere between 1 and 2, right? So like there'd be a point there. And then there's also negative root 2, which would be somewhere on the left side in the negatives. I can graph those. But for x equals the positive and negative, like I root 2, those aren't x-intercepts, right? We've talked about this many a time. That if there's an I, that means it's an imaginary number. I don't see any i's on my x-axis. I can't graph that. So, for all intents and purposes, and I don't know why I said it all fancy like that, but for our answer, only 2 of those zeros were actually x-intercepts. So we found that there were 4 zeros, but only 2 of them were x-intercepts. So again, I did all of those in box method. So if you are a fan of box method, you can click off the video now. I'm gonna go back up to the first one and show how to do it in long division for those of you who actually like that. But if you were following along with just box method and you want to stick to that, by all means, you're all done. You can watch the other video or go work on your formatives. On the test, again, you don't need to do any specific method, so it's whatever you prefer. If you only like the box method, you can stick with the box method. My thing stopped. I deleted everything but what I wanted to delete. Nope, it's there. So anyways, I know it's still all like highlighted and stuff, but if I had, it's not a radical, I know it kind of looks like it. If I had 2x cubed minus 9x squared plus 3x plus 4, and I'm dividing by x minus 4, I gotta figure out, well, how many times does x go into 2x cubed? We've been talking about like how we do our little tiny boxes, where like x minus 4 is on the outside. I know 2x cubed is on the inside. Well, I know x times 2x squared gets me 2x cubed. So then in my bottom box, I get 2x squared times negative 4 gets me negative 8x squared. So then I move to subtraction. I subtract what I just got in my box. I subtract a 2x cubed minus 8x squared. But this is where some people might run into trouble. I know 2x cubed minus 2x cubed, that goes away. And then negative 9 minus a negative 8. I talked with a few of you guys about how when we subtract a negative, it's the same as adding a positive, right? So if I'm doing negative 9 minus a negative 8, that's the same as negative 9 plus 8. That's just negative 1 x squared. Another thing, you know how I got this 2x squared? I'm going to write that as part of my answer up top. So now I can move on. I'm going to erase my box just so I can have the room. Might have to scroll down as well. have to bring down that 3x now. So I have negative 1x squared plus 3x, right? Yeah, get rid of that as well. It's just annoying. So I have x minus 4. I can do my little box again if that helps you guys. I have x minus 4. And I know I need negative 1x squared. Well, I know x times a negative x would get me negative 1x squared. And then negative x times negative 4, well, that's just 4x. So I subtract again. I subtract a negative x squared, and I'm subtracting a positive 4x. Negative 1 minus negative 1, that's 0. So those go away. 3x minus 4x, that's just a negative 1x. 3 minus 4 is negative 1, right? And I bring down the negative 4, or the next term. But again, I keep forgetting to do this first, but I found that I had to multiply by negative x, right? That means I'm writing that up top. So far, I know that my division is the 2x squared minus x. And then now, another box, I know I have x minus 4. Let me erase this box so we don't confuse ourselves. I have x minus 4 on the outside, and I need negative 1x. Well, x times negative 1 is just negative 1x. Negative 1 times negative 4 is a positive 4. So again, I subtract negative 1x minus a negative 1x, and I'm subtracting a 4. Negative 1 minus negative 1, that's 0. Negative 4 minus negative 4, that's also 0. Right? So I end with 0 or no remainder. That means my final function is the 2x squared minus x minus 1. So that's how we would have done long division. You would still have to put this like 2x squared minus x minus 1 into like reverse box method, or however you want to go about factoring to find those other two factors. But sometimes it might just tell you to do the division, right? There's going to be problems like the one we did on the bottom, like, actually, hold on, scratch that. You're going to have problems where it just tells you to divide a polynomial by like x plus 4. And then this would be your final answer, unless there's some remainder, right? Like if this was a 5, we'd end up with a remainder of 1. Then our function would have to tack on like a 1 over x minus 4. Stop it. Let me write it, please. There we go. I'd have to tack on that 1 over x minus 4. I'm not sure if there's any remainders on the problems, but be on the lookout, because there might be. I just don't have the test memorized right now as of writing this. But yeah, if you watch these videos and think, oh, hey, there's something else that I have in mind that he didn't go over, reach out to me on Schoology. Can you do a video of you solving this problem? And there's a very high chance that I'll do it because I care. And I want you guys to pass this test because I know it's hard. And, you know, having only two summatives in a marking period, that summatives are 80% of your grade, it's pretty scary, right? But I understand it. I was a high schooler back in my day. Anyways, good luck on the test.